negative 4 from either side from the absolute value of x plus 4 divided by 2x plus 8. And we know that every time we calculate a limit, what will be our first step? Exactly, plug it in to see what type of limit that is. And there are several reasons why, and one of them is, I will refresh your memory, I will repeat this over and over. There are 7 indeterminate cases. 7 indeterminate cases. Notice that I did not say undefined cases. I said indeterminate cases. So we're going to add to this list throughout this semester, throughout the first 2 chapters, basically. So 2 of them I would like to add right this moment. 0 over 0, and the other one infinity over infinity. So these are 2 out of 7. So there are 5 more to discuss. I'm going to add as we encounter them. We're going to discuss all 7. Okay, so I would like to establish this from the get-go. Well, when you plug in negative 4, the numerator is 0 and the denominator is 0. Would you agree?
Yes.
Good. So that's one of the reasons why I wanted to not wait till the next chapter to discuss this. So this is one of the indeterminate cases. What does indeterminate mean? It means that the answer can be anything. Anything. For example, it can be 10, it can be negative 3, it can be 0, it can be 1500. I don't know. When we say indeterminate, we can expect anything. Really, anything. Okay. Now, the problem it will ask me, definitely, to simplify this expression first, the function first. In order to simplify the function, we have to review the absolute value definition. Can anyone refresh our memory on the absolute value? What are the options? So one option is x for x greater than or equal to 0. The other option is negative x for x less than 0. This is the formal definition of the absolute value. But this is not how I would like you to remember it. This is how I would like you to remember it. Oops. This is how I want you to remember it. What does this all mean? What does it mean? It means anything. It means you name it. As long as these 5 quantities are all the same. 1, 2, 3, 4, 5. And this one has a minus in front. So I meant not to write x. Forgive me. So whatever greater than or equal to 0, whatever less than 0, and all these 4, sometimes I put a square, sometimes I put a triangle, sometimes I write ex like an expression, whatever. So then when I continue with the absolute value of x plus 4, once I understand this procedure, all I have to do is copy. That's all I'm doing. So in these 5 spots, I put x plus 4. That's all I did. But this is good, but it's not good enough. At this point, I have to change this into x greater than or equal to negative 4. I refuse to look at this one because if this one is greater than or equal to negative 4, this must be less than negative 4. you don't have to erase it. Please don't erase it. I'm making a point to tell you that you should never even look at this. If this is x greater or equal to -4, this must be less than -4. If this is x less than or equal to 10, then this must be x greater than 10. Whatever it's not here, it must be in here, and you don't have to waste your time solving this. Okay, so I have the simplified form of the absolute value of x plus 4. Don't forget to stop me if you have questions. I'm looking to see if I am still focused right. Okay. So now the function is x plus 4 divided by, I see 2x plus 8, and of course I'm going to factor out a 2. And because this portion of the function has two options, the entire function will have two options. And can anyone give us the first option? Anyone? If the top is x plus 4 and the bottom is x plus 4, what is left?
1/2.
Very good. So this is for x greater than -4. How come that I did not copy this? This says greater than or equal to -4, but I only copied greater than 4. Why is that?
Because it can't equal.
Why? Excellent. Why?
It will be 0.
In the
Denominator.
perfect. Excellent. So then I can safely copy the other one. That's not a problem. But can anyone simplify the other one for us? If the top is negative x plus 4 and the bottom is 2 times x plus 4, what should the answer be?
-1/2.
Excellent. After I simplify this function, I can go back to the limit, finally. And I can write, since it's 0 by 0, I'm looking at the limit as x approaches -4 from the left, and the limit as x approaches -4 from the right. So which function do I write here, and which function do I write here, and what is the answer?
-4 from the left will be 1/2.
Careful.
Right?
-4 from the left would be
X less than -4. So -1/2.
very good. And the answer is -1/2. We know that the limit of a constant is the constant itself. And then on the other side, of course, is 1/2, and the answer is 1/2. So what do I conclude about the limit as x approaches -4 from either side from the absolute value of x plus 4 over twice the absolute... What is the final simplified form or the answer for this?
It does not exist.
Excellent. Well done. Thank you. So that's how we deal with absolute value limits. We have to completely simplify the function to the fullest and then answer the question. Is this okay?
So why is it D and E again?
The limit from the left does not equal the limit from the right. There's a theorem called a squeeze theorem. Because in certain situations we will have a hard time applying anything that we studied. Factoring, rationalizing, simplifying, etc. So here is a situation. Let's suppose I have no algebraic way of determining the limit. And I have a function, let's say this function is this, I'm going to call it f of x. And there is another function, let's say that is this. And let's suppose I have a function that is right in here. I'm going to call it h of x. And this is x equals a particular value of x. Okay, so the question here is, find the limit as x approaches a from either side from h of x. This is our question. Okay. Number one, and remember we have no algebraic method. We cannot do anything. We don't have any options here. If we have options, we don't have to talk about the squeeze theorem. Squeeze theorem is applicable in only specific situations in which my hands are kind of tight, and in specific type of problems. So number one, tell me whether this is correct. Near x equals a, of course this is, yes. Well, whatever that song was, I'm sure it was very good, but can you please mute yourselves? Okay, so near x equals a, tell me whether this is correct. H of x is squeezed between g of x and f of x. Near a, when I say near a, I really mean near a. Would you accept this? I don't care what happens here. I don't care what happens here. Maybe it goes over. I don't care. But I do care what happens near a. Would you accept this statement?
Yes.
Thank you. Now, assuming that the limit from f of x, when x approaches a from either side, exists, and furthermore, equals the limit of g of x as x approaches a from either side, and I'm going to say that they both exist and they both equal L. These are the two hypotheses of the squeeze theorem. Both have to be fulfilled. Otherwise, the squeeze theorem is not applicable. Then, what will you tell me? What is your conclusion about this?
That h of x must be equal to g of x and f of x.
We're talking about the limit.
The limit of them are all the same. The limit of h of x is also L.
That's it. That's the squeeze theorem. But we have to make sure that both conditions are fulfilled. So from, and this is what you have to put in writing, from 1 and 2, comma, by the squeeze theorem, limit of h of x as x approaches a from either side is L. Just common sense, right? It's clear. So let's work on a problem. And here it is. I'm going to look on the same page, let's say 41. And we have limit of x to the fourth times cosine 2 over x equals 0. They say, prove that. Prove it. Any questions before we continue to 41? Anyone? Any questions? Please feel free to stop me. Okay. Good. So first of all, I have to plug it in like we always do. And I know that this approaches 0. I know that 2 over x, it doesn't even exist. The limit when x approaches 0. I'm going to graph the function on the side. The limit from the right and the limit from the left of 2 over x. This side is infinity, this one is negative infinity, so this is d and e. And no, you cannot say that 0 times d and e is 0. So then, let alone plug in d and e in cosine. I have no idea what that is. So nothing that we studied so far, other than the squeeze theorem, is applicable here. But I have to decompose this function. And at some point in time, 2 weeks ago, we talked about cosine. So cosine of whatever. What do we know about this function? We know that the function is bounded. Bounded function. Bounded below by and above by. What is the minimum possible value for cosine? What is the maximum possible value for cosine? No matter what.
1 and negative 1.
Excellent. Very good. So as you see, the function I have to build is something times cosine. I already have this piece. Now, how do I insert in here somehow an x to the 4th? Applying mathematical legitimate operations. So what should I do to all 3 sides to get that x to the 4th specifically in front? But I cannot just do it to the middle. What should I do to all 3 sides? Because the function is x to the 4th times cosine. Any suggestions? What should I do?
Multiply all of them.
By?
X to the 4th.
Right. Excellent. However, I have to be careful. 2 things have to be fulfilled. This quantity cannot be 0. If I multiply by it and it's 0, then everything collapses. Can it be 0? No, because when we say x approaches 0, we really mean it. What do we mean by that? That x is not 0. So that is fulfilled. Also, the same quantity has to be positive. Because if it's not positive, I have to switch the inequality symbols. Is it positive? Is it positive?
Yes.
No matter what, x to the 4th is always positive. So these 2 conditions are fulfilled, so then I can go ahead. Negative x to the 4th less than or equal to x to the 4th, cosine 2 over x less than or equal to x to the 4th. And I can see now that the first hypothesis of the squeeze theorem, the first hypothesis is fulfilled. I have the function squeezed between 2 functions. I'm going to call this function f of x, or g of x. It doesn't matter really, call them as you like. And this f of x. I see that the first condition of the squeeze theorem, or hypothesis of the squeeze theorem, is fulfilled. Now the question is, will the second one be fulfilled? I don't know. I have to determine the limit of negative x to the 4th when x approaches 0 from either side, and the limit of x to the 4th when x approaches 0 from either side. So then, what is the limit of this and what is the limit of that? Can Can anyone tell us these two limits? Give us these two limits. No one? What is the limit of negative x to the fourth?
I don't think anyone knows.
Aww. We have to plug it in, right?
Or doesn't want to speak up.
Oh, that's fine. I have to plug it in. And it's a number. I'm done. I don't have anything else to say. So then, from 1 and 2, comma, by squeeze theorem, what do I conclude about limit of x to the fourth cosine 2 over x as x approaches 0? Definitely guaranteed. The answer is 0.
I have a question.
Please do.
So when you were breaking down the squeeze theorem for this particular problem, you separated f of x and g of x into x to the fourth, and then I don't think I understand how you separated the f of x and the g of x to compare it to h of x. Does that make sense? Like, for the second step,